Hello everybody. Today's problem of the day for quadratic problem solving is about Logan and Cassidy leaving a campsite on their bikes. It's kind of a ridiculous problem because how would we know that they're 68 kilometers apart after 4 hours but not know how fast they're biking? It's kind of a silly problem, but it is great for problem solving because it forces us to combine many of the ideas that we've talked about throughout the school year. First of all, I see there is, Logan and Cassidy riding bikes. Logan's riding north, Cassidy's riding east, so they're headed in different directions. And when I look at the given information, first I see 7 kilometers per hour slower than Cassidy, so that's referring to a rate, speed. 4 hours is referring to a time, and 68 kilometers refers to a distance. So somehow or other, these are going to be distance, rate, time problems because I have distances, rates, and times as given information. So let's see if we can unpack it and get everything straight. To start with, I'm going to define my variables, but I'm also going to connect some of the variables right off the bat because there's a lot going on. First of all, we talk about Logan's distance. Distance equals rate times time. So R1 would represent Logan's rate of speed, and time would be the time that Logan was riding his bike. And if you multiply how fast you go by how long you ride, you get how far you go. Same can be said for Cassidy's distance, although she's traveling at a different rate. So that's the other thing that we know. The rates are connected because whatever Cassidy's rate is, if you subtract 7 kilometers per hour, you've got Logan's rate. The other thing I know, by the way, I'd also drew in Logan going north and Cassidy going east. We'll label that in just a moment. But this is the other thing I know that makes the problem far less complicated than it could be. We know that at 4 hours they're 68 kilometers apart, so I can use 4 hours for Cassidy's distance and for Logan's distance, so we can just work with two variables. So in the first case, we can see Logan has his rate has been adjusted, 7 slower than Cassidy's rate, times 4 hours is how far Logan went. So when I distribute and get 4r minus 28, that represents this distance, the length of this side of the triangle. Cassidy's rate is 4 times r, and so that's a distance, and that represents the length of this side of the triangle. I used r instead of r2 for simplicity. So we'll understand now that r is representing Cassidy's rate, r2, for the rest of the problem. Now, I was just trying to figure out, ooh, that went really fast, what would happen if I just had Cassidy riding at 10 kilometers per hour. And let me back up here, I hit a button. If Cassidy's riding at 10 kilometers per hour, then Logan is riding at 3 kilometers per hour, much, much slower. But then I could use this 10 kilometers per hour and put it in here and figure out how far both Logan and Cassidy went. 4 times 10 and 4 times 10 minus 28 gives us 40 kilometers and 12 kilometers, and this is after 4 hours at this rate. And I just want to see how close they are. In order to do so, I have to look at this distance, which represents the hypotenuse of a right triangle. And that leads us to the Pythagorean theorem. The distance I need, if I squared it, it will be equal to the sum of the squares of the two legs. The rest is algebra. We've studied this before. We get a distance of 41.76 kilometers, which is shorter than the desired distance of 68 kilometers, which means Cassidy was riding too slow. 10 kilometers per hour is not fast enough, so I will have to have a larger rate for Cassidy in order to get 68 kilometers apart after 4 hours. So let's jump to generalizing and stop guessing. We'll go straight to the result that we need. In much the same way as when this was 40 and when this was 12, I can still use the Pythagorean theorem and state that the length of the one leg squared plus the length of the other leg squared is equal to the hypotenuse 68 squared. And this is an equation with just one variable in it, and I can solve it. So the rest of this lesson is about using the algebra that we've been studying to solve this equation. First, to deal with the squaring. A reminder right here that 4r squared is the quantity 4 times r times 4 times r, giving us 16r squared. 4r minus 28 has to be FOILed, and that's where this result came. And the rest then, I need to collect like terms. And at this stage, oh, there again, I bumped the wrong button. I got too big of fingers. Here's the equation, and I noticed that all of these are even numbers. In fact, I actually decided to divide everything by 16 just to see if I can get smaller coefficients. So I divided left and right hand sides, every coefficient by 16 to get these smaller numbers. When I subtracted 289 from both sides, I recognized that I could still divide out another 2 yet and get a really nice clean quadratic equation from this. In hindsight, I realized maybe I could have divided out some numbers here in the beginning to make the problem simpler from the start. But nonetheless, I did break the equation down to a nice quadratic, which is easy to factor, relatively speaking, and I get two numbers. I get -8, which is not a viable speed for a bike, and 15, which is faster than 10 kilometers, so I'm pretty sure I'm on the right track. If Cassidy is going 15 kilometers per hour, then Logan is going 8 kilometers per hour, and that is confirmed. At least the solution to my equation is confirmed using technology. The only other thing that I would do is go back to here, and where it says let R2 equal 10 kilometers per hour, I would change that to 15. And if we put in 15 here and here, we would end up with 60 minus 28, or 32 kilometers for Logan's traveling, and 60 kilometers for Cassidy's traveling. And a short check with a calculator would show us that 60 squared plus 32 squared is in fact 68 squared. So that's how we would be able to check our answers, and using the most base form possible. Rather than checking my equation, which could be wrong, I go right back to the triangle and find the distances after 4 hours, given the rates 15 kilometers and 8 kilometers per hour. So thanks for watching. Have a great day.